Alright, today I want to talk to you about how to complete the square. So typically the question is asked, find the roots of the equation x squared plus 8x plus 11 equals 0 by completing the square. Alright, so there are two things that you need to complete the square. You need to have a 1 in front of the x squared term and nothing where the c term is. And right now we have an 11. So what we're going to do is move the 11 to the right by subtracting 11 from both sides to get our equation ready in order to complete the square. Alright, so I get minus 11 on the right side. I have nothing where the c term would go, referring to ax squared plus bx plus c equals 0. So this is called standard form, descending order. Okay, and the a coefficient needs to be 1. There has to be nothing where the c is, and we're ready now to complete the square. So in order to complete the square, you take half of the b coefficient, which is 4, and square that number. And add it to both sides. Because since it is an equation, I can't simply add something other than 0 to the left side if I don't add it to the right side. So I now have x squared plus 8x plus 16 equals negative 11 plus 16. So this is x squared plus 8x plus 16 equals 5. This expression right here on the left side is now what is called a perfect square expression, because it can now be written as x plus something squared, and that something is half of the b coefficient, 4, because 4 plus 4 is 8, and 4 times 4 is 16. That's the relationship, this number to these two numbers right here. And now all we have to do is take the square root of each side. And if you take the square root of an equation, of both sides of an equation, you have to throw in a plus minus sign on one side to admit for two possible solutions. So last step, x is equal to negative 4 plus or minus the square root of 5. Or, if you prefer, negative 4 plus the square root of 5, negative 4 minus the square root of 5. And here are the solutions, the roots, solution to the equation we were given to start with. Alright, so this is completing the square. If you have a 1 for the leading coefficient, it gets a little bit more difficult if you have something other than 1 for the leading coefficient. So I'm going to tackle that one now with you. So let's say we have an equation like 2x squared plus 10x plus 9 as an example. Alright, well the same conditions apply. I need a 1 right here, so I have to divide everything by 2 to get a 1 right here, and I can't have anything where the c term is. I have to have blank space right there. So I'm going to have to do two things in this case. I'm going to have to divide everything by 2. And of course 0 divided by 2 is still just 0. So that gives me x squared plus 5x plus 9 over 2 equals 0. And then I'm going to move the 9 over 2 over to the right. Alright. Then we do the same thing we did last time. Okay. Take half of the b coefficient and square it and add it to both sides. Okay, so again, take half of this coefficient, divide it by 2, and square it, add it here, and add it here. This is now a perfect square. So I can rewrite it as x plus 5 over 2 squared equals, and here we have to do a little bit of fraction arithmetic. So we're going to do negative 9 over 4, 9 over 2 plus 25 over 4. And I need a common denominator here, so I'm going to do negative 18 over 4, so I multiplied by 2 over 2 in order to get 18 over 4 to get my common denominator, plus 25 over 4, and this will give me x plus 5 over 2 squared equals, so negative 18 plus 25 is 7, and I now take the square root of each side. Same rule applies as last time. We have to put down a plus minus to admit for two possible solutions, and take the square root of 7 over 4. Square root of 4 is 2. So x is equal to negative 5 over 2 plus or minus square root of 7 over 2. And we can combine the two terms if possible, if you want, because we do have a common denominator. So we can write that as negative 5 plus or minus the square root of 7 over 2. And there are your two roots to your quadratic equation obtained by completing the square.